Hello there, this is exercise 10B. It's one of two PowerPoints looking at how to differentiate products of functions. Now you may recall, posh word product really means times. So it's when you get two functions times by each other. For instance, it might say x squared sine x, for instance. And here we've got one function, we've got another function. And as a general rule, what we do is we write one of them as u and the other one as v. And our formula that we're going to use is based around that. You should recall the notation for differentiation. You've got two choices, well three choices I suppose. You've got, in this case, it's normally dy by the x, but in this case I've written du by the x because I'm calling my function u. Or it might be dv by dx. But you could also write u dash. That's often a notation used. Now if your function is called f of x instead, you'd call it f dash of x. And that's what you'll notice we're doing up here. This is what all this is about. But let's get on and do it. First of all, a bit of a starter for you. This is the chain rule on the whole by the looks of it. So I'll do the first one for you. You've got to be a bit careful. The first two are polynomials to a power. This one you've got e to the x's, and here you've got logs. So you've got two of each. So maybe I'll do one of each. So anyway, here you bring the, so if I want dy by dx, I would bring down the 4 to the front, 4 lots of x cubed minus 2, now to the power 3. But don't forget to times by 3x squared, which is what I get when I multiply, or I differentiate that bracket. So I finish with 12x squared times by the x cubed minus 2 all cubed. So it's quite a lot of work just to get there. This one's a lot easier, by the way. Do y by the x on this one. And by the way, be careful when you do this one because this is, you've got to change the power. On this one, you bring the 4 to the front and you just get 8e to the 4x. I did say that one was a lot easier. But this one, when you get logarithms, you can find dy by the x because it's always, effectively, it's like 1 over that thing. But then you have to times by the differential of 5x, which is 5. So weirdly, in this particular case, it doesn't always do this. The answer is 1 over x. So there's three others. You might want to pause it now to see if you can do the other three. Okay, here goes. Here's the answers to them all. Some of them might be rearranged. The good news is I have got the three I did right, but you've got the other three hopefully right as well. So the product rule then. So what does it look like? If we've got two functions, there's one, there's another. There's one, there's another. So it depends on the function itself, but you'll notice in each case this is times by this is times by this. And so in those cases we think of one of them as u and one as v. It doesn't matter which way round you call them in actual fact, u and v. Now this is one way of writing it. Notice dy by the x is u times dv by the x plus v times du by the x. Well, it's actually easier writing that. Y dash is uv dash plus vu dash. So perhaps I'll use this notation. But you can use either. You won't get told it, so you're going to have to learn that rule. So here's an example or two. So let's do number 1 first. So it says y equals x to the 4 sine x. So I'm going to write u equal to x to the 4. And since I've got this formula written up here, I'm just going to differentiate it. U dash is 4x cubed. V then is the other one, which is the sine x. Now you should remember that v dash, if I differentiate sine, I get cos. What can I do with that? Well, now I can say dy by the x equals u. Now notice what you do here. You are going to times that x to the 4 by that there, and then you're going to times the sine x by that there. So that gives me x to the 4 cos x plus 4x cubed. No, I'm just putting that thing first. Now I could take out some kind of common factor actually, so I could, if I was so inclined, factorize it. It doesn't make it any better unless you're doing something else with it. Plus 4 sine x. Oh, one of them is wrong. It's that one. That should be an x. Nearly got that wrong. Because x cubed times x give me that. That's better. I think that's the answer to the first one. And for the second one, let's just do this one as well. Again, u might as well be the e to the x. Now the nice thing about u dash then is it's still e to the x. If I write v equal to cos x, now again remember sine, cos, minus cos, you can see cos becomes minus sine when I differentiate it. chuck it into my formula. dy by dx equals one diagonal e to the x. Well, I've got to put a minus in front of this because I've got a minus on the sign, plus e to the x cos x. And again, you can factorise this. Again, e to the x goes into both. I fancy writing that cos x first because it's positive, minus the sin x because it's negative. X cubed, that's what I've got written the other way around, but it's basically right, and I've written it the same way there. So a couple of examples for us, quite nice. Just more variety now. So y equals e to the x. So this is my u equals e to the x, and my u dash must be e to the x. My v equals log x, and you need to remember that v dash becomes 1 over x. So chuck that in to get dy by dx to know where the answer is going to come up. I'm going to try and write this quite small. So it's that diagonal, e to the x. You could write it over x, plus e to the x log x. See if that's the right answer. Well, interesting, again, I've taken out e to the x as a common factor, which is right, and then you get that back again as 1 over x. So that's right. And this next one, again, now it's slightly a bit, I'm going to write u equals e to the 2x, that's not a problem. But notice I'm going to have to write v. If I'm going to use the product rule on this, I've got to write it as 1 plus e to the x, but it's on the bottom, so I've got to write it to the minus 1. Now there's an alternative way to do that later on. It's called the quotient rule, which is what you get if you do divides instead. But we haven't done the quotient rule yet, so I've just done it like this. Differentiate e to the 2x, you get 2e to the 2x. Differentiate that, well, bring the power to the front, 1 plus e to the x, to now drop off the power, times by the differential 1 plus e to the x, which is just e to the x. So you'll notice I'm getting e to the x, well, minus e to the x, 1 plus e to the x to the minus 2, and even that can be rewritten if I so choose. So what do I think the answer is? I'm going to write it over here because I suspect I'll overlap it otherwise. So it's, remember, it's the diagonal as you do it on that. So it's e to the 2x times by, well, it's it's minus e to the x. And this, what I was hinting now, you can write that slightly better. 1 plus e to the x squared, and it goes on the bottom. But then don't forget this one, plus 2e to the 2x. And again, it's to the power of minus 1, so I'm going to write it over 1 plus e to the x. That's an x. There's better ways to write that, I suspect. Oh, right. Do I prefer that? Well, interestingly, this one, they've just multiplied it out. I've got a minus, they haven't. Is it mine that's wrong, or is it theirs? Or is it just a simplification? So I'm just going to try and simplify this. Now e to the 2x times e to the x is e to the, you add the power, 3x. But I've got a minus in front. And it's over this. They've written 1 plus e to the x. So they've put it all over that. Well, this one is already over that, so that's fine. But this one isn't already over that. So you can see, if I'm going to write it over 1 plus e to the x squared, I've got to times this top bit by 1 plus e to the x. And if I times it by 1 plus e to the x, I get 2e to the 2x plus 2e to the 3x. So that's giving me an extra couple of e to the 3x minus that. So this is actually right. So they're exactly the same as mine, but theirs is just written slightly prettier. Now the big debate then is when when do you stop? And normally it'll be fairly obvious or it won't matter. So I wouldn't worry too much about that. So we've got 3 last examples where we just says just use the product rule. So I'll just go through each one. This is root x. I'm going to write u equals x to the half. It's much nicer. And immediately I can write u dash is a half x. Drop down the power minus half. And I suppose the good thing about this is it's showing you that there's lots of different things we need to be able to differentiate, and your job is to make sure you can. This is like a chain rule question again. 3 comes to the front. Drop down the power. But don't forget to times by the differential of the bracket, which is 2, which is 6 lots of 2x plus 1 squared. Now when you chuck these in, when you get these things where you can see they're very similar, you probably will be able to simplify something along the way. So anyway, what am I going to do? I'm going to say dy by dx equals and the equals diagonal that times that. So I might as well write it as root x now, times by this. And then this times this. And that's a half. So plus, now that's actually best written 1 over 2 root x. The half there, root x, is on the bottom because it says minus. But that is then times by, what we got, times by that. Well, I might as well put it here as well, 2x plus 1 cubed. Now it does say write this in fully factorised form. So the only thing I'm thinking of is I've got 2x plus 1 squared, I've got 2x plus 1 cubed. Let's take out the 2x plus 1 squared. And then in a bracket I get 6 root x, perfect. And this is plus 2x plus 1 over 2 root x. Now that's a debate as to whether or not you go further or not. That's good enough for me. That's good because that's the answer. Second one, what's it? Oh, have I got it? Yes, I have got it eventually. So u equals x cubed. Now look, this one looks a lot easier. V equals the e to the x, and it's just easier functions to deal with. So this is 3x squared when I differentiate. This is still e to the x, and so dy by the x, diagonals, x cubed e to the x plus 3x squared. This is this diagonal now, e to the x. What comes out? Well, a couple of things come out. See, e to the x comes out as a common factor, and x squared comes out as a common factor. It doesn't matter which way around you write that. But here I get x plus 3 in a common factor bracket kind of thing. There you go. In fact, yes, they've written those the other way around, but other than that, and then x plus 3 the other way around, but other than that, they're the same. And I think this is our last example. So what have we got? We've got y equals x squared. So u equals x squared. U dash equals 2x. Hopefully you're good at differentiation in those. But v is this slightly more complicated, x squared minus 2x to the 4. This will require the chain rule. Bring the power down to the front. X squared minus 2x now to the 3. Don't forget to differentiate the bracket, which is 2x minus 2. Okay. Times those together when we do our dy by dx product rule. I'm going to write, well, I've got a 4 already, I've got an x squared, I'm going to write 4x squared times by that 2x minus 2 times by the x squared minus 2x cubed, and then I've got to add this one. It's 2x x squared minus 2x to the 4. And immediately I think I can take 2x out as a common factor. I can take out that bracket to the power 3, x squared minus 2x to the power 3. And what am I left with? What am I left with? I've got a 2x from this, times by the 2x minus 2. And on this one I've got plus, I've got one of those brackets, x squared minus 2x. So I think I can probably simplify that square bracket a little bit, 2x. X squared minus 2x cubed, and this square bracket might be able to be simplified as well at the end. I've got 4x squared plus another x squared is 5x squared. I've got minus 4x minus 2x, I reckon is minus 6x. Yeah, you can see both of those are x's in. So my final answer I think is going to say 2x squared. I've taken the extra x out. X squared minus 2x. And now this will just say 5x minus 6. I think. Oh, they didn't take out the x squared, so they could have taken out an x squared as well. For once, mine is the better one. Other than that, that's what we're going to do in class, and hopefully you'll be able to make good progress with that. So best of luck.